Now we're on question 4, and question 4 says state the value of theta when t equals 0 in this expression. So if t equals 0, then e to the 0 is 1. So this is 120 minus 100. Which is 20. In part B, we're told that when T equals 40, the temperature equals 70. Therefore 70 is 120 minus 100 times e to the minus 40 lambda. So we need to solve this equation. So let's bring this expression to the left-hand side, bring the 70 over the other side. So we get 100 e to the minus 40 lambda equals 50. So therefore e to the minus 40 lambda is 50 over 100. So therefore minus 40 lambda is ln over half. So therefore lambda is minus 1/40th of ln to a half. But it says we need to give the answer in the form ln a over b, where a and b are integers, and a half is not an integer. So let's write this as 1/40th of ln of a half to the minus 1, because a half to the minus 1 is 2. So it's 1/40th of ln 2. And now in part C, when theta equals 100, t equals capital T, so therefore 100 equals 120 minus 100 e to the minus lambda t, capital T. So let's bring, as before, let's bring this expression over here, and let's put the 100 over there. So we've got 100 e to the minus lambda t equals 20. So therefore e to the minus lambda t is 1/5, 20 over 100 is a fifth. Therefore minus lambda t is ln of 1/5. Therefore t is minus 1 over lambda ln 1/5. What was lambda? Lambda was ln 2 over 40. But lambda equals 1/40th ln 2, so therefore t is minus 1 over lambda, so that's 40 over ln 2 times ln of 1/5. And it says give your answer to the nearest whole number, so this works out to be, not minus, works out to be plus 92.87712338, which is 93 to the nearest whole number. Now we're looking at question 5, and it says that x equals 4y minus sine 2y squared. And in part A we're told that y is pi over 2, so therefore x is 4 times pi over 2 minus sine, well 2 times pi over 2 is just pi, and sine of pi is of course 0, so this part is 0, this is 2 pi, 4 divided by 2 is 2 pi, so it's 2 pi all squared, or 4 pi squared. Either of those answers is okay. Now in part B we've got to find the coordinates of A, because we need to find the tangent to the curve at P. So we need to find dx by dy. So we've got a bracket to the power 2, so when we differentiate it, it's 2 times that bracket to the power 1, and then I've got to differentiate the bracket. 4y differentiates to 4, sine 2y, well sine goes to cos, but then differentiate 2y, we get a 2. Now we're told that this is the curve, the tangent to the curve at P, so at P y equals pi by 2, so therefore dx by dy is 2. 4 times pi over 2, that's 2 pi. Sine of 2y, that's sine of 2 times pi over 2. 2 pi over 2 is pi, and the sine of pi is 0. Oops. Didn't really need to put that in, but there it is. And then we've got a 4, and then we've got cos of 2y, or 2 times pi over 2 is pi, so it's the cos of pi. The cos of pi is minus 1, so it's minus 2 times minus 1, that's plus 2. 4 plus 2 is 6, 6 times 2 is 12, so we've got 24 pi. So the equation of the tangent is y minus y dashed, so that's y minus pi by 2, equals m. Well, the gradient is dy by dx, so from here we can say that dy by dx is 1 over 24 pi. So it's 1 over 24 pi x minus x dashed, and that's 4 pi squared. That's what we got back here. So we're on the y-axis, x equals 0, comma there, x equals 0, so y minus pi by 2 equals 1 over 24 pi times 0 minus 4 pi squared. So therefore y minus pi by 2 equals minus 1/6 of pi, so therefore y is pi by 2 minus pi by 6, which is pi by 3. So therefore the coordinates are 0, pi by 3. I haven't got room on this slide to write that in, but that's what I should write down at the end. The coordinates are 0, pi by 3. Now we're on question 6. We've got a curve and a line intersecting, so at the intersection 2 to the x plus 1 minus 3 must equal 17 minus x. So therefore 2 to the x plus 1 is 20 minus x. So therefore x plus 1 is log to the base 2 of 20 minus x. Now they've got it in terms of log to the base e, so let's change this to log to the base e, that's ln of 20 minus x, and the change of base formula we need to write log to the base e of 2 there. So therefore x is ln 20 minus x divided by ln 2, take away 1 as required. Now in part B, x0 equals 3, so x1 is ln of 20 minus 3 over ln 2, take away 1, that works out to be 3.087, that's to 3 decimal places. So x2 is ln of 20 minus the previous answer. I'm going to write 3.087 here, but obviously use your previous answer to get it exact. That works out to be 3.080 for 3 decimal places. So x3 is ln of 20 minus, well I'm going to write 0.080, but use the answer function on your calculator. That's minus 1 to get 3.081, again to 3 decimal places. Let's just write 3 decimal places there, which covers everything. And now part C, it's clear that x is going to be 3.1 to 1 decimal place. So if I put 3.1 back into the formula for y, and y, the easiest one is 17 minus x, 17 minus 3.1 is 13.9. So the coordinates are 3.1, 13.9, and that's to 1 decimal place.